Welcome! I'm afraid Rod Martin is at it again. He claims to have exposed a third global warming lie, namely that global warming causes extreme weather. This video is going to take a look at whether any of his arguments hold any water, and spoiler alert, they don't. Let's first understand what extreme weather is. Extreme weather includes tornadoes, hurricanes, droughts, heavy precipitation, both rain and snow, coastal flooding and flash flooding, and heat waves. But Martin only deals with the first two of these, tornadoes and hurricanes. I wonder why. And here's the reason why. This diagram shows the relative amount of evidence that these extreme weather events are linked to human-caused climate change. And you'll see on the far left of this figure that tornadoes and hurricanes have the weakest evidence. So Martin is choosing the softest targets to attack here, while ignoring the strongest evidence that is available for a link between climate change and extreme weather events. He starts off on the wrong foot by making a couple of very basic scientific errors that just demonstrate how little he knows about this subject. He claims that 0.55 into the video, wind is caused by temperature differences. Without temperature differences, air has no reason to move. And then a little bit later on he says global warming will reduce the temperature difference between the pole and the equator, eventually eliminating strong storms altogether. It is a pressure difference that causes the wind to blow. Here is the gas equation. It's very simple. It says the pressure times the volume of the gas equals the number of molecules in the gas times a constant called the gas constant times temperature. Now if you take the volume from the left hand side and divide it into the number of molecules, you have a number divided by a volume, which is a density. So you could express the gas equation simply as the pressure equals the gas constant times density, rho, times temperature. So how do you in an ideal situation get a wind to blow? In these two volumes, volume 1 and volume 2, the pressure on side 1 is greater than the pressure on side 2, so a wind will flow from left to right. Now that can happen in a number of different ways. You can have the pressure on side 1 higher than pressure on side 2 if the temperature on side 1 is greater than the temperature on side 2 for a constant density. Similarly, for a constant temperature, you could have the density on side 1 be higher than the density on side 2, and again a wind will flow from left to right. Or you can have a combination of the two where the multiple of the density and temperature on side 1 is greater than the multiple of the density and temperature on side 2, and again you'll have a wind blow. There are other types of winds that don't require a temperature difference. There's the Santa Ana winds, where air from the high plateau filters down through the valleys between the mountains, compresses and heats up as it reaches the coastal parts of California. So to take one of these factors in the gas equation and say this is solely and only the reason why a wind blows is utter scientific nonsense, and Martin should be ashamed of himself. To be honest, this next bit is not really relevant, but I found it so funny I thought it would be worth including just for the laugh. He asked the question, does the sun send pressure beams at the earth? No, there is no such thing, he declares. This of course is ridiculing the fact that pressure differences cause the wind. But I've got news for him. The sun actually does send pressure waves towards the earth. It's called the solar wind, where the pressure in the solar wind can change by orders of magnitude from day to day or even from hour to hour. Sometimes embedded in the solar wind are coronal mass ejections, which create even more extreme pressure conditions in the solar wind. So indeed, the sun does send pressure waves towards the earth, but they don't affect our weather in any particular way, so as I say, it's not particularly relevant. At one point he shows this figure as though it justifies his case, where he shows some sinking cold air gravitating towards warming rise air, creating a wind. And he states that the greater the difference in the temperature between these two, the greater the wind. Of course, in this respect, he's full of hot air. So let me show you what really happens. Let's assume we've got a piece of land shown here in green, and the air just above it is characterized by a temperature, a pressure and a density, which we'll call P1, T1 and ρ1. Now the sun comes out and shines on that land and heats a patch of it up. Now the air immediately above that land will interact with it and it will warm up. So the temperature in that volume of gas, T2, will be greater than the surrounding temperature, T1. So the pressure in that volume of gas will be greater than the surrounding pressure. So P2 is going to be greater than P1. What happens when you have a volume of gas at a higher pressure than its surroundings? It expands. So you get a new volume of gas, a much larger volume of gas, where it's expanded until the two pressures are equal. The temperatures will be still greater than the surrounding temperatures, but now the density of that volume of gas will be much less than the density of the surroundings. And what happens then when you have a less dense volume in a more dense medium? It will start to float. It's called buoyancy. So that volume of air will start to move up. And it'll keep on moving up until it reaches equilibrium with its surroundings. And of course remember that the pressure, temperature and density of the air changes as you go up with altitude. A new volume of air will rush in behind it. Because it's replaced with the surrounding gas, the temperatures will be the same. But because you've evacuated a space of the atmosphere, the density will be much less. So the pressure in that volume will be less than the surrounding pressure, and so the pressures will try to equalize, and that will draw in a wind. So the wind is formed now by a pressure difference, not by a temperature difference. He now sends in the straw man. He says global warming alarmists believe that global warming will warm the oceans, causing the hurricane threat to increase. Now certainly the scientists say that global warming will heat the oceans. That's part of global warming. But do they say that the hurricane threat will increase? We'll see. He then follows that with the statement that a warmer planet will end up reducing the temperature difference between the equator and the pole, eliminating strong storms altogether. We'll see about that in a minute too. Well, the difference between the temperature at the pole and the equator is not going to go anywhere anytime soon, as I'm about to explain. We know from the tilt of the Earth that each pole does not see the sun for about 6 months of the year, so by definition that's going to be very cold there. And because the sun is shining on a sphere, the polar regions get much less energy per unit area than the equator does, so there's always going to be a temperature difference between the two areas. Now we know that the Greenland ice sheet is about 3 kilometers thick, and the Antarctic ice sheet is about 5 kilometers thick, and it's going to take millennia for each one of those to melt. So for the foreseeable future we're going to have two large lumps of ice near the polar regions, driving that temperature difference between the equator and the poles, and hence driving some of the weather systems. As the range of temperature from the equator to the pole is much greater than 50 degrees centigrade, and sometimes greater than 100 degrees centigrade, the change 2 to 4 degrees centigrade is not going to make a great deal of difference to the temperature gradient. After nearly 10 minutes of faffing around, he actually gets around to the point of his video, namely talking about tornadoes and hurricanes and how they're affected by climate. He makes a statement: the number of strong tornadoes in America has declined in the last 60 years, and shows this plot, which if you sort of blur your eyes you see some sort of trend, downward trend in these data. But he equally could have shown you this plot, which shows an upward trend in the total number of tornadoes. Now what's going on here? Of course it's possible to have fewer strong tornadoes while overall having more tornadoes. But really it's something much more fundamental than that. Apparently, according to the experts, changes in the population density, the way that damage assessment was made back in the early days of this plot, and observational procedures have changed in a way that makes the comparison between the older and new data unreliable. So what the scientists are saying here is we don't have the right sort of data to be able to tell whether there's a trend either way in these tornado data. So any conclusions about whether it's increasing or decreasing is sheer and utter nonsense. Next he moves on to hurricanes. He states, fact, global hurricane count has also declined, and then shows this picture by a fellow called Mao. Now I'm not seeing a particularly strong trend here. in the data. It's possibly the eye is being fooled by this very high peak right at the very beginning and the low peak at the end. But if you backed up a couple of years, there's seemingly no trend in this data at all. No significant trend in this data. You could say the same for this major hurricane strength, that's the bottom curve. However, it does sort of appear that it's slightly increasing, but again, it doesn't look all that significant. Now, the thing about this is that he makes this statement, yet there's a paper by Wenkel, Mao and Pilkey in 2012 that says the analysis of this plot shows that there's not a significant long period global or individual basin trend in the frequency or intensity of landfalling tropical cyclones of major or minor hurricane strength. So basically the people that produced this data that he is quoting says there's no trend in it, yet he is saying it's a fact that global hurricane count has declined. He concludes his video with the statement, conclusion, global warming will end up creating a far more peaceful Earth. But unfortunately, conclusions based on a lack of understanding of the basic physics, misunderstanding or misrepresenting the data are unlikely to be valid conclusions. As far as tornadoes and hurricanes are concerned, we don't know as yet if global warming is affecting them or not, and if so, in what way. Scientists are working on that. That's why you'll hear these debates from different scientists, some saying that the numbers or the intensities of these things are increasing, while others are saying it's not. That debate will go on until there is sufficient data to differentiate between the two positions. That's how science works. Until next time, goodbye.